right, so we are going to do an example problem that sort of puts all of this stuff together with regard to electric potential. So electric potential energy, electric potential, voltage, potential difference, those are the same thing, kinetic energy, the work energy theorem, all this stuff, electric. If you have not done so yet, or if you want to review, go back and watch that kind of introductory video on electric potential. Kind of goes through a lot of different ways to think about it, and we're going to put all those different ways to use. So we have an electron, a charged particle, acquires 4.65 times 10 to the minus 16 joules of kinetic energy when it is accelerated by an electric field that's between two plates, plate A and plate B. So two charged plates, an electric field is generated between them. We know that when I have two plates that are close together, it's a uniform electric field that is generated between those two plates. So we're dealing with a uniform electric field. What is the potential difference, the voltage, between the two plates, and which plate is at a higher potential? So when we go back to thinking about our work energy theorem, we know that the change in kinetic energy is equal to the work. And we know that the work is equal to minus the change in potential energy. So this leads to our change in kinetic energy equaling minus the change in our potential energy. And you can go back to your Physics 1 material when you were first introduced to the idea of the work energy theorem with conservative forces, conservation of energy, and that is where this kind of stems from. Not kind of, it does. That's where it stems from. All right, so if that's the case, and we are told that the electron acquires, it changes 4.65 times 10 to the minus 16th joules of kinetic energy. Your problem's up there, my problem's down here. So that means that the change in kinetic energy is a positive 4.65 times 10 to the negative 16. Right? That equals minus the change in potential energy. So this tells us that the change in potential energy is minus 4.65 times 10 to the negative 16 joules. Okay, so it tells us the change in potential energy is minus 4.65 times 10 to the minus 16 joules, because minus and minus gives us that positive kinetic energy. So this is our change in kinetic energy. Make that arrow there. And that implies our change. So not a lot of math in this one, just a recognition that the kinetic energy is related to the potential energy. It's opposite the potential energy. Okay, so that's part one. In our problem, it does want to know what the potential difference is. So we're going to use this information to determine the potential difference. We know that the potential is equal to the potential energy per charge. It's the definition of potential. So our potential difference is equal to the change in potential over the charge. Potential difference, remember, I'm going to put kind of a bold B, that's our voltage. Okay. So our potential difference is minus 4.65 times 10 to the negative 16. Our charge, well, this is an electron. Remember, the charge on an electron is equal to minus 1.6 times 10 to the minus 19 coulombs. So minus 1.6 times 10 to the 19th. That's going to equal our voltage, 2906 volts, which also, incidentally, as a reminder, has unit of V. So you got to keep a little track of your V's, right? Voltage, potential, volts. All right. Okay, so this is our potential difference. That's the answer to the question that we care about. What is the potential difference? Now, if I have two plates that are producing this potential difference that the electron is experiencing, which plate is at a higher potential? Well, it's going from plate A to plate B. Our change in potential, our potential difference is positive. So B has to be higher than A. Okay. All right. So just kind of using not difficult math, just kind of remembering how potential energy is related to kinetic energy. It's related to electric potential. And then potential difference. All right. Good job.